Hello, everyone. Welcome to the next Construct Innovate webinar on digital construction technologies. My name is Magda Hajdukiewicz. I'm a co-director of Construct Innovate, Ireland's National Research Centre for Construction Technology and Innovation. And today's webinar's topic is on artificial intelligence, virtual and augmented reality, and 3D scanning. We have three fantastic speakers with us today. The first one is Rina Garrett from Arup, speaking about machine learning, artificial intelligence, and generative AI. Our second speaker is Greg Byrne from BAM, speaking on virtual and augmented reality in construction. And the final speaker is Jared Coleman from Murphy Geospatial, who will be presenting on laser scanning, BIM, and the importance of geospatial information. Following the presentations, we will have a short Q&A at the end. So if you have any questions to our speakers, please put them in the Q&A box at the bottom of your screen. So without further ado, I'm going to ask Rina to share her slides. And for everyone, I hope you enjoyed the webinar. Thanks, Rina.
Thanks, Magda. Can everyone see? Can you see that now?
Yes.
Okay. So I'd just like to say thank you to Construct Innovate for inviting me to present. It's really exciting for me to be here to talk about something I'm passionate about. And I hope it builds on the previous webinar that our learned friends Louise Fuddy, Ralph Montague and Casey Rutland gave on the adoption of digital in the construction industry. So today I'm going to give a brief overview of artificial intelligence and machine learning, describe some of the opportunities in the built environment and some of the challenges that we face. Just a little bit about myself before I begin. I'm an associate in Arup. I'm the technical delivery lead for digital services in Arup Ireland. I have over 26 years experience as an IT professional, and I've worked across a number of different industries in that time. So online poker, manufacturing, mobile, and technology. For anyone who isn't, oh, sorry, I just want to go back for a second, sorry. Just to explain, my little avatar is, I'm a total geek and nerd, self-confessed, and came up with my own Star Trek avatar. Just to talk about Arup. Arup is a global company. We're in 34 countries and have employ 18,000 people worldwide. Our philosophy is to shape a better world through sustainable development, and we can use these technologies to improve the way we deliver our services in the built environment. The technologies are constantly changing and improving, so it's vital to stay up to date with them. So what is artificial intelligence and machine learning? Artificial intelligence is generally accepted to be an algorithm or program that has the ability to learn from experience. It can teach itself basically, whereas a machine learning algorithm has to be taught or trained by presenting it with a set of data first that it can learn from, and then you give it the blind set of data that it can use to do its job or its prediction. Some of the opportunities that are available or that are open to us now in artificial intelligence and machine learning in the built environment would use things like generative AI, which an example of that would be, say, for example, when they're coming up with new Elvis songs from old Elvis songs, that's generative AI. So you could use that in design and planning of a floor layout. If you fed it loads of previous floor layouts and told it which were the optimal ones and that you wanted something that satisfied certain parameters, it would generate a numerous options for you. So kind of design planning, optioneering, you could use generative AI for that. Computer vision then is the use of machine learning on images and video, so you can use that to classify images or to identify features within an image and to pull that out and tell you what it is. And also within video, so say for example ANPR on road tolling, so it would be able to pull out the actual number plate and identify what that number plate is using machine learning. Predictive analytics, an example of that would be forecasting. So for example, it could be used in risk analysis or risk forecasting in flooding, flooding risk projects, things like that. It does a lot of, you can do time series analysis and pull out information, what you think is going to happen. Obviously, there's an accuracy percentage that has to be taken into account with those results, because it's not going to be 100% accurate. And then we have genetic algorithms, which would be used in optimization problems. And I have a case study later on that will go into this in more detail. When I was preparing for this presentation, I went to ChatGPT, which is in the news all the time at the moment because it's going to take over all our jobs. But oops, it wasn't available. So it was really heartening, I suppose, to see that, you know, these technologies are fallible as well, and we're not all going to be replaced. Just a little bit more about the computer vision. So you can see here in this image how an image or a scene from a video has been taken, and it has put little boxes around each of the objects within that image. So it's identified which are the cars, which are the vans, what the signs are, who the people walking across the street are. And that would be an example of a classification using machine learning and computer vision machine learning. And then just to go into a bit more detail about the genetic algorithms. So a genetic algorithm is kind of based on the theory of evolution, if you like. You know, it uses the steps inspired by evolution. So it would do random mutations within a set of population, crossovers, and selection of the best. So you would pass it in a population of data, and it will analyze that data against a fitness function. And if it says, oh, well, these aren't great, they're not coming out with the right value, it'll get rid of some of them or mutate others, or select some to keep, and then it will go around and pass that in as a new population, and it will keep doing that until it converges with the fitness function to come up with the best values. So just moving on to the case studies. Okay. So I have 4 case studies that I'm going to go through. My favorite one is the one I've highlighted here in red. That's the last one I'll detail. But before we get to that one, I'll just do a little bit on the other 3. So this is Loop 360, which is Arup's tunnel inspection tool. So we developed Loop 360 to inspect the inside of tunnels. It's 360 cameras and LiDAR, I think, on a trolley that runs through the actual tunnel and takes pictures and video of the whole tunnel system. And then that imagery is passed into a machine learning algorithm in the back end, where it has been told what to look for. So it's already been trained for issues that might occur and features to pick out, so like a crack in the tunnel or water seepage. So in this one here, you can see that it's actually shown where there's water coming in the tunnel, and those ones will be, each feature then will be classified as, you know, bad and really needs attention, medium, can wait a little while, or everything looks good. So that's an example of computer vision at work. The next one I want to talk about is one we did for a transport client in Ireland. This was a project that we used k-means clustering on. So k-means clustering would be a machine learning algorithm that's considered unsupervised. So it's not been trained on the data, and its job is to discover relationships between the data that you give to it. So we have passed in a number of different data sets: the weather data, the traffic count data, vehicle speed data, and accident data. And we've asked it to find clusters within that data to give us insights back that we can interpret and then give to the client. And one of the things that we discovered was that accidents are more likely to happen on a sunny day than a rainy day. And this was really interesting for the client, and they were super excited about it. About just going on to a slightly different topic would be the data engineering effort that went into this project. So it was about 80%. So gathering all our data, making it all mash together, but all the ETL, which would be the extract, transform, and load. Whoa, going ahead of me, I better stop. Okay, so the next one is the healthcare client. And for a healthcare client in Ireland at the start of COVID, when obviously there was a massive demand on the oxygen capacity when the hospitals were filling up with COVID patients, we did this project for a healthcare client who didn't have smart meters at their location. So what we had to do was get a subcontractor to go out and put cameras in front of the digital meter that was on the oxygen tanks and take photographs of that and send that data back via API to us, where we put it through a convolutional neural network with a number of different layers that we had trained to see different digital values. So they all varied from place to place. They weren't always identical. And then we did optical character recognition on those digits and were able to interpret the reading from the meter. And we fed that into an analytics engine and trended that over time, and we're able to display that then in the web front end to the client. And finally, if the slide will move on. Oh. My favorite one, which used the genetic algorithm, which is the Whole Foods project. Sorry, I'm having technical difficulties with my slides. This was done by my colleagues out in San Francisco. Whole Foods are a supermarket chain in the States, and they came to Arup asking them to help them reach net zero on a particular building that they had in San Francisco. California has really strict regulation for commercial buildings around net zero, achieving net zero by 2030. So Arup were hired to do this for this Whole Foods building, and they combined their mechanical engineers and the building engineering domain expertise with machine learning to come up with an algorithm to generate interventions that, or a combination of interventions that could be used to reach this net zero for Whole Foods. So initially, the domain came up with 107 possible interventions, but what they wanted to know was what was the best combination of those 107 that they could implement that would give them the energy reductions, but also come in under budget because they had a certain budget. So the possible permutations of that 107 interventions was a 27-digit number, which you can see up here. And obviously, no human can work through that many numbers combinations. It would take them 10 years. So you can see here I've shown the engineer going from a young lad to an old lad. Over that 10 years, he's gone grey. So what they did was they used a genetic algorithm to do the iterations for them. So they fed in the population of all the value of all the interventions, and the genetic algorithm came up with 2,400 plus costed plans of combinations that they could use. And then the engineers went through the best 100 of those ones and came up with the right interventions for that property, and resulted in a 46% energy savings for the client. Some of the considerations and challenges then that we have within machine learning are and AI are bias and variance. So bias is where it's a measure of the accuracy of a measure of the error within your model. So what are your predictive values compared to what are your actual values, and what's the difference there? What's the error? And then the variance is how well, actually I find variance really hard to explain. So variance is where how well is your data, is your model fitting your data? So you can have a problem where it's fitting too well when you've shown it so much data that it's actually interpreting all the noise in the data as well and fitting it too well. So this is called overfitting. And generally there's a trade-off between bias and variance, and you have to get the balance right between the two. The National Institute of Standards and Technology in the States has a really good, I think it's like an 180-second video on their website about bias in artificial intelligence. It's worth a look. And then obviously ethics is the other big one. What are the ethics about this, and who's controlling it, and who's regulating it, particularly in relation to artificial intelligence? So I've listed a few of the ethical considerations there in the text, in the small text. One of them is obviously the dual use dilemma. Are we developing something for good? Will it be used for ill? How can we prevent that? One of the things that's very important for engineering companies is transparency and explainability. And how can we explain the number that we came up to? Like, how is that explained? Can we write it out, and can we underpin it with facts? And the way you would do currently in your traditional disciplines, if we use machine learning, how do we explain the value we got to? And then another one would be autonomy and accountability. So, for example, with self-driving cars, if you come to a quandary, which pedestrian do we knock down? That kind of thing. So my key takeaways for this, I suppose, are oh, come on. AI and machine learning, they're just another set of tools. We should embrace them. They will make things, they can make things easier for us and quicker for us, and open up other opportunities for us that wouldn't have been there before. And they're not going to go away. So as the Borg say, resistance is futile. So we may as well embrace them. And the final question then obviously is, will we be replaced? And I don't think so, because somebody would still have to program these two guys. So for programmers, there'll still be a job, but AI is in its infancy at the moment, really still. So we've just scratched the surface of what's possible, and we have a long, long, long way to go before we'll be under threat. Maybe our great grandkids or something. Thank you.
Thank you very much, Rina. Very interesting presentation and great overview of case studies from Arab. I may ask now Greg to share his slides, and we go to the next presentation.
So my name is Greg Byrne. I'm head of digital construction within Ireland for BAM. I've experience about 10 years in digital construction, and I've a further about 15 years in architectural technology before that. So I've always been a technology lover, a bit like Rina, and that can be an issue, especially around emerging technologies where we mightn't realize that we're kind of a little bit ahead of the curve and even ahead of the actual technology when as it's being implemented. We accept there's maybe issues around it where it needs to be a little more embedded before it becomes something, but I'll talk a bit about that later. So just to touch on BAM first of all. It's changing, yeah, there we go. So BAM are part of a wider BAM Ireland are part of a wider group, Royal BAM, and we have offices in the UK and Ireland, Belgium and the Netherlands, and quite a diverse amount of projects within that and departments. So we've covered a lot of different types of projects, which we have then opportunities to use these kind of technologies. So what I'm going to talk about today is why look at AR or VR, what's the benefits, how are BAM utilizing, and then what should we ask ourselves when we're thinking about using these technologies. So first of all, we really need to look at the spectrum of reality. So on one side we have virtual reality VR, and the other side we have reality. So one side's completely immersed, the other side is not. And then somewhere between we have augmented and again a variance of that. And these technologies are called mixed reality. a new phrase that's come along is extended reality, which takes into account the whole gamut of those virtual and augmented realities, and the technologies are described as immersive technologies. So VR isn't something that isn't new. It's been around for years. We have the kind of the early users of it were game technology around PlayStation, Samsung Gear, the original Oculus. So they were kind of like the basics when it came in. We've seen in the recent years Microsoft, Meta buying Oculus for Meta Quest, and Apple Vision entering the market very recently. So you can see that there's a lot of interest from the bigger players within technology in AR and VR. And why is that? Well, it's projected that by 2028, the market value will be 58 billion. So that's rising about 12 to 13% per year until 2028. So there's a lot of space to move in this, and that's why I believe that the main players are starting to take an interest. So a bit like AR, mobile technology, we went through a period where we're very comfortable. Everyone knows this type of image where you span around a dial, very easy to use, and it became commonplace, and that was in place for years. And then we went through an awkward teenage years of mobiles where people started to carry around the phone with them, and it was a little bit awkward. People didn't like to be seen with them. It wasn't cool. And then we matured and the technology became better. Apple really made a change with the iPhone, and Android took suit. And it's commonplace, and it has really exploded. The amount of power that you have in your hand has really become a huge benefit to your own social life, your work life, and it's not frowned upon or even considered is it a benefit anymore. So we are currently in the VR AR comfort zone. I believe we are using technologies like we're on a call today. We're in a virtual environment. We can share images, share presentations, look at models, etc. And we're very happy with that. And we've got good, especially with COVID over the last couple of years, people who weren't technology lovers have become, Teams advocates. They can see the benefit, or Zoom, etc. But we're moving into that awkward zone where we don't really know how the technology is going to land. We don't really like the headsets on our heads walking around. It hasn't become normalized. We have kind of pockets of excellence, and then it doesn't really appear in our daily lives, apart from some use cases. So we're in that kind of awkward zone at the moment. But we're moving into that acceleration stage. So we start to see heads-up displays on cars, within mobile apps like Google Maps, as is shown there. You can see the augmentation of the view within the phone come through. Simple application, works really well. And that's where we need to be. Even Pokemon was a huge hit, I think about 2017, in a virtual environment. Very simple idea, simple game. That's where we need to get to. So what is BAM doing around AR, VR? We're actually doing quite a lot. We're trying to really see where the value is in this. So I'll give some examples. So 10 years ago, we started using Autodesk BIM 360 Glue. Very simple application on an iPad, using the model, looking at a plan view, selecting the room that you're in. Then the model will appear on your iPad. You rotate yourself to match the model. You hold the button that's shown on screen there, and you simply move the iPad around. Very, very simple to use, zero setup. And it became a great use to validate information on site. So that was a very simple use of AR. We have used that for the last 10 years with great effect. We're going to play a little video here. So this is from an airport project. So we're using Gamma AR, and I don't know if you can hear the sound. I'll turn that down a little bit. Maybe a little bit more. So very similar. You select a wall on a plan, you orientate the virtual environment to that model, and then you get that insightful model experience directly over your view. So this is an excellent use of it. We found great value on this. The problems around it are really the time it took to get the models into the software, and then alignment. So as you set yourself within the room, if you move through space 20 or 30 meters, the model starts to become out of line because of the original inaccuracy when you set it up. So good basic value, but it's another step that it takes to get that value from it, which isn't always ideal. You want things to be as easy as possible. But in terms of coordination on site, you can see how valuable this is, walking around the site, looking to see if that cable tray is aligned, is correct, or has there been any changes on site. You can spot them very, very quickly. So I'll just stop that one and move on. Do I need to get to the end? Okay, so that was for buildings. That works well in a building situation. However, infrastructure, which we do a lot of, it isn't great because you need kind of fixed positions, and you mightn't also have those fixed positions in the real world in a kind of a linear infrastructure point of view. So you can see here, we're using a product called VJS. We've been working with our client, who it's always great when you get a client that is can seize the value in this and wants to try something different and you know, be a leader in it. So this is, I'll play the little video here now as I'm speaking. So you can see the pipe work, you can see within the ground, you can walk around. You've got a clear view of where the pipe is running. Even the white lines are marked on the ground. I think one of the takeaways from this was actually some of the line markings weren't painted where they were in the model, and we recognized that we hadn't completed it as required. So the problem with this was the time that it took to get the models into the system. It's getting better and better. And where we see it going is that point clouds would be visible in this environment as well. So as you're completing the work, you scan the area, you see the surfaces. The surfaces may not be perfectly aligned as per the model, especially in cabling situations. And you can then actually see the real environment below. So that's for infrastructure. So this is another application we use on a dock project in the UK. So it was for induction. So you're coming to site, you're looking at the site for the first time. So they have built this. So you go into a cabin, you have all the setup there available for you, and you start to walk the site and be led through the site and brought through a question and answer session just to orientate you with the site and the constraints. So you can see there, you can locate yourself, walk around, and at each marker, there is a set of questions that you have to answer around the site setup. So very useful. They found it, you know, excellent resource, but again, it was time that it took to set this up, and maybe it could be done a little slicker. I'll just move on from that. So the obvious example is design and coordination around AR and VR. So it is one of those go-tos that we've used for years, very beneficial. And a lot of architects would use this in terms of conveying the intent of a design to a client, or even within coordination within the construction phase. It's very useful to be able to see it in 3D, bring in expertise, especially people on the ground that may not be using technology, to put on the headset and allow for coordination. So in this BAM Designer, using it to allow the client to see their building, to experience that and give a real sense in a 3D environment what it will look like. It's very common technology but it works well, and I believe that's where we need to go to with the following on technologies. So I'll just pause that, move on. So barriers to adoption. It's slow to set up. You may need expertise in doing so currently. The UX can be a little unintuitive, needs a better way of interacting. The technology is lagging, and we're seeing that change now with the investment. So hopefully that will get better and better. The headsets will be able to hold bigger models. Self-conscious is one of those kind of social aspects, a bit like the mobile phone. Currently on site, you wouldn't, it'd be a bit of a joke if you're walking around with a headset on, and there's also that health and safety aspect of that. So it's important to recognize we have to get over it kind of socially, and a cost aspect. As this is such new technology, it is really to break that barrier of cost, bring it into something that's very readily available to the public to use, and it'll become something of a mainstay. So we have to frame all this with the question of value. So we can't be doing this for just for the sake of it. So I'd say first thing we need to do is look at the value and doubt it. Really prove the worth of the technology. What are we gaining from it, and what is the potential? So we're at the start of this curve in terms of technology around AR, VR. It's got huge potential, and if you're behind that curve, how long is it going to take you to catch up? So that's why we're keeping right at the edge of this, and hopefully it'll become really a ubiquitous kind of technology in the future. And fundamentally, what problem is it solving? We shouldn't be using technology just for technology's sake. We should be using it really to meet a problem that we're having, and it isn't hugely clear what problem we're solving with this. We've got great ideas about it, and it could be of massive benefit on site, especially with that augmented overlay of the model on site. Huge potential in that, but we need to be clear about the problem we're solving. And finally, this is the goal. It really is to bring benefits from information and data straight to the user on site, whatever you're doing, or in the design office, bringing that, overlaying that data in the real world. It could bring massive benefits, and this is really the goal that we're aiming for. So that's it for me. Thank you very much for listening.
Thanks very much, Greg. Brilliant, great presentation with the, showing the potential of those technologies. Thank you. I may ask Jerry now to go ahead with his presentation. Jerry, do you want to share your slides, please?
My name is Jerry Cowman. I'm a senior geospatial consultant in the digital engineering department for Murphy Geospatial, which is in short laser scanning and BIM. So hope you enjoyed the next presentation on laser scanning, BIM, and most importantly, the geospatial information. Murphy Geospatial are one of the largest dedicated survey companies in Ireland and UK. We capture, collate, verify, and govern geospatial data, and enabling our clients to make informed decisions across the project lifecycle. We understand the importance of geospatial certainty with a goal to deliver maximum benefit from the geospatial information, and by supporting our clients to deliver solutions to key industry challenges. We're across 6 sectors here with proven solutions in the design, construction, and in-use phases of projects. We're celebrating our 40th year this year, and with over 27,000 individual surveys and a 350 plus staff, we're quite established across the British Isles and Europe also in a few locations. So laser scanning, what is laser scanning? Many of you here today will have come across a total station in your career, and in its simplest terms, a laser scanner is a souped up evolution of the total station using angles, distance, and known locations. Rapid capture of the current site conditions is what a laser scanner is best used for. It involves using the laser beams to precisely measure and capture the shape, contours, and details of the objects and environments. By emitting laser pulses, it shoots it out and returns it, and it knows its time to create the highly accurate 3D representations known as the point clouds. These clouds consist of numerous points in a known position, XYZ coordinates, longitude, latitudes, millimeters, eastings and northings, allowing for different modeling and analysis capabilities. Laser scanning finds wide applications into fields like surveying, architecture, construction, archaeology, and manufacturing for tasks such as creating 3D models, precise measurements, and as-built verification. We get often requests for give me a point cloud or give me a laser scan, but to get more value from your point cloud, a better understanding of what technology is out there, the precision and the details needed, and the application can open more usability and longevity from the initial cost. It's more understanding what can actually be done, down the road than the initial short-term kind of solution or the short-term request. Once the laser point cloud is captured, you get a grayscale or a 3D or a colored point cloud as such. And the point cloud is then processed and traced along the digital representation of the physical object, and the 3D digital design takes shape. I wrote this earlier before I listened to the Rena and Greg, but it's still currently mostly a manual process. But we have heard from the previous two presentations that automation and AI improvements are evolving each year to a point where the main point is automatic feature extraction will reduce much of the manual works. You can see here that the different colorization of the gray point cloud really, emphasizes the different aspects. And what I meant before is we could fully capture a rail line like this and draft everything, but really all that might be required or needed is the location of the 4 orange pits down the center of the rail line there. So a better understanding of what's actually needed, can save time and money by better understanding what the last end use application is. In regards to automation, are we worried? Not really, because with the advancement of the software data sets and AI and the use of rapid capture, it means that it's going to be more applicable and more required, and the hardware will still be even more in demand. And the field surveyor to operate the equipment and understand the space is still going to be in demand. The few showcases spot the dog with a laser scanner is running around on many of the campus floors, and that has a use and a tool. That tool has a use, but for certain instances, that's not applicable, or for certain instances, you need to climb up a ladder that Spot can't do. So the manual or the personal touch is still going to be there until they make bipedal robots like Rena's last slide in the future. The rapid capture tools, they do reduce time and team sizes. They are slowly improving efficiency, and Murphy Geo, we do have each of these items within our arsenal, but it's just for better understanding of what's actually needed. We can assist and suit the survey to your needs. Generally, we're asked for, as I said before, we need a point cloud or we need a scan to BIM model, and a scan to BIM is, it's a brilliant piece of visual tool. It's a process using the point cloud to generate the digital representation of a built asset or a digital twin, a real-time asset, typically requiring 3 stages: the data collection, the processing, and the drafting. Each stage of the process has potential to determine information, and the scan to BIM representation accumulates into a specified exchange format. It's when you drill down into BIM, it does turn into much more. And my next slide apologies. Going back, there is the automation process is slowly building into this also, and geometric description languages and multiple COBie and NBS toolkits, are being prepared and built that the automation can take into effect. But there are still concerns regarding the accuracy of this process. In 10 years' time, it could be different. In 30 years' time, it could be even more improved again. So time will tell on the uptake and on the costs needed, but at this stage it is still quite a manual. But BIM itself, BIM should be considered more of a process. Building information modeling is probably, it was a term coined too early, and it should be maybe more building information management. with, as you can see here, the famous iceberg image where the 3D model is the most visible, but it's the data and the information or lack thereof that may sink your Titanic. The BIM model creates the comprehensive digital representation of the building or the infrastructure and encompasses the 3D models with the detailed information, the materials and the systems. But there's still two parts of the management system: the collaboration hub as the central platform for the stakeholders. It enables the real-time sharing and integration. And then the decision support system, the processes where BIM facilitates the informed decision-making throughout its life cycle, allowing for the simulations, analysis, and visualization, aiding the design, validation, clash detection. By starting with the end in sight and following the processes defined by the BIM standards, and there's ISO is the main one, more value can be gained from BIM. We're often asked for said scan to BIM 3D model, but we follow the ISO 19650 when we do drill down the PIR, the CDE, and the EIR to get the better use from the end of the end use application. Many of our clients are, "Oh, just give us a model." So they're paying for this additional, or you're paying for this additional service that you could be getting better value for, and bringing that model all the way through from conceptual stage one into design handover and asset use. BIM, according to the ISO 650, is a sequential process of utilizing the digital collaboration towards achieving the good information practice. It's not just a model. It steps from concepts and principles delivery phase, which is probably where most of ourselves here are based in, through to the operational phase, which will be getting more and more focus in the next couple of years with sustainability and the shortening building stock. The information exchange is the historical information as it's brought forward, and then the information security as all of the previous building passports are built up. That's going to come more into the fore, where the information could be potentially jeopardized by poor folder structures. But the fact that they're actually taking information security into account this early within their processes, it just shows that the foresight in ISO 19650 is there, that it is going to be something that needs to be talked about in the future. Within Ireland, the next slide might be a refresher to a few people here, but that the Irish BIM mandate for government works will take effect into the new year on a phased basis. The BIM requirements for government style works starting at 100 million, basically any government project over 100 million is needed to be BIM deliverable, and that's not just the BIM model, but following all the ISO processes. And over the phase of 4 years, that's going to come down to projects below 1 million. This will probably be a challenge for some stakeholders within this BIM project or within these BIM projects, but it has worked quite successfully over the UK, the BIM level 2 mandate. And it's just something that us as members of the construction sector, we must consider BIM as that process that governs the creation and management of all the information on a project before, during, and after construction. The life cycle information management process is key, and it's changing on for the projects, or the BIM doesn't die with the end of a closeout of a project or a red line drawing. These BIM models or BIM process is planned for asset use and onwards. So the more it's actually built up, the golden thread in the earlier days, the more information that can be brought through onto the next part of the project. It does, within this BIM mandate, I might be contradicting myself, but it doesn't require a 3D model per chance, as it is a process. As long as certain steps are taken and best practices used, the BIM model itself or the 3D shape might not be needed for certain aspects. So somebody who might be a painting contractor, even though it's on a BIM project, they don't need to have a BIM model of a millimeter thick painting or paint layer on a wall or 2 coats. But if they follow the project information model and the asset information model by uploading the paint type or the time between each coats, that's how someone in that sector might be able to add to these digital projects and the the sectorization, you know, everybody can be brought in. It'll come to a stage where nobody can be potentially left behind, whether it's by their own decision or by their own and lack of understanding. It will go through there. And as Greg mentioned, the technology advancements are offering alternative digital representatives, which can be utilized to build our built environment. So the AR and the VR, when it does become more cost savvy or more accepted, you know, that will come into it. But there's the next slide, or the next few slides, is where it is the key point. I'm going to skip over this quick little video because I don't think we might not have time. But the geospatial information, the location data, the understanding of its accuracy is the key point in the previous two presentations as well. And just it's the data, the science of location is a major point, and it's often overlooked, and that the surveyors are capturing like a known piece of information, a known piece of data, and it has value at that time. That value at that time can be expressed throughout the digital delivery of a project, and all aspects of the information, the design, are based on a position, and it has value. So by capturing the reality of the site conditions versus the digital design, the world, it's important to understand that we are delivering on what was intended, you know, and that's where the verification piece comes in. You know, by figuring out what's there with a laser scan against the BIM, you know, you can be informed of how slow your project is going, how many clashes are made, and understanding your information a bit better. The next slide here is something that we developed, and from the previous two presentations, we might have to do an optimized 4.5 where it talks more about VR and AI, but it's kind of like level of detail or level of information. It's just an understanding of our clients' geospatial maturity and where they are, and with this BIM mandate, it's going to come more and more into the floor where, you know, how do I get, I'm ad hoc, I'm level 1, how do I get to 2, how do I get to define 3? And as we are surveyors, we're there to consult and help people to build that information and optimize for, you know, it doesn't need to be a full-on BIM model, but just respecting and understanding the information and knowing its worth is probably key. The next few slides will just be a quick case study of real world examples where understanding the importance of the geospatial information and remedying the issue found rather than thinking it's bad for the construction progress has saved a lot of time. So what I mean by that is a laser scan to BIM or a laser scan verification. Here they realize the lift walls are out of place. You know, it costs €10,000 to fix it at that time to slow the program. At an earlier stage where the surveyor might have been considered crazy or mad or just redline it out, down the line that could have been a $500,000 to $800,000 modification. The same can be said for the HVAC duct, a simple HVAC duct. You know, it's fine, you know, we have no space to move it, or changing an angle, you know, a resolution cost, and it could have been it for any reason, but you know, that saved 15,000 and by doing regular as-built updates of a project or midway through, you know, can give you a better understanding of where you're sitting and on how you are, and it's understanding the geospatial information with the BIM and the laser scanning, I suppose, that can you know, really give you more value. And when it comes to the final delivery, you know, you could be more sure that there's going to be no kickbacks or any changes, or now it's probably more so where the asset owner is coming back and really reviewing that information and coming back. I'll just end it there because.
Thank you very much, Greg, and thank you, Jer and Rina. Fantastic presentation. So on behalf of Construct Innovate, I want to thank you so much for committing time to present for us today. To all our attendees, I hope you enjoyed the presentations. This is the third webinar of the Digital Construction Technologies topic. We have 3 more topics to go. Next one next week on the 28th of November. And I also want to say big thanks to Sinead from Engineers Ireland, who is facilitating the webinar series for us in the background. So thank you very much and have a good day.
Thank you.